Antares on its way.
It's true that quantum mechanics is the science of the very, very small, but due to sort of a twist of fate, it's also the science of the extraordinarily cold. This idea, this sort of relevance, this connection between the very, very cold and the science which underpins the very small, which underpins the future of our economy, is not a new idea. In fact, there are hundreds of groups around the world here on Earth, including mine, which are studying this thing called Bose-Einstein condensation, with this idea in mind. But up in space, we hope to be able to get colder yet. We hope to get to temperatures of about something less than 1 nanokelvin. So we intend to get to within 1/1000th of a degree of absolute zero.
I always ask students, what's the most widely used material on Earth? And the answer is water. What's the second most widely used material on Earth? And that's concrete. For every person sitting in this room, there is 1 ton of concrete being produced and consumed every year. We really need to understand much better what is happening with this material and how we can use it more sustainable on Earth, and how we can make a usage of raw materials present in the space and make a binder, concrete-like, cement-like binder in the space. So if we can make the process pure, because we know from protein research that the crystals will go larger and more ideal in its shape, if we can narrow down the amorphous phases and the crystal phases forming hardened cement paste, maybe we can improve the process on Earth.
So here we are doing essentially a fundamental paradigm shift in the way people have processed chemicals. So we're shifting from a gravity-based paradigm to a surface forces driven. This is the device that we are sending to space. We hope to learn more about how this device works in order to make it better, and so this would benefit Earth applications, hopefully pharmaceutical production. In terms of exploration of deep space, you need to have the capability of making molecules. So you need chemical processing capabilities, and this, if it works in the way we hope, would enable certain steps in order to pave the way towards chemical synthesis in space. And of course, there's a very exciting horizon.
All 3 of us up here have projects that are based on the use of small satellites called CubeSats. All 3 of these projects are Earth-observing missions. From the ISS, we later in the summer get pushed out into orbit, into free-flying orbit. We've built a new processor that's a very capable processor. It'll be the first time a processor like this has been used in space.
We still don't know exactly when the cloud forms and when it rains. And we need to observe these storms as a function of time at one space. So this whole project is about developing all the technology that what we used to do from huge systems into shoebox size.
Right now it's a technology demonstration that is, if successful, soon we'll see constellations of these small radars together with radiometers, which will significantly improve weather and climate forecasting and our understanding of the water cycle.